Hello class, welcome to section 2.7, derivatives and rate of change, day 2. Today is day 2 of 3 on section 2.7. So we're going to continue to look at derivatives. Okay, so what is the derivative? Okay, the derivative notation is f prime of a, or you could also say f prime of x. Okay, that's your notation for derivative. And derivative is the slope of a tangent line. If you remember, we started chapter 2 actually quite a while ago. When we first started out chapter 2, we started with all these secant lines. So here would be an example of one secant line. And then we would take our secant line and continue to use point P and move it closer and closer and closer to our tangent line to get a good estimate or limit as it approached that point. Okay. When we looked at the limit, we could find what the slope would actually be when you were just at one point. So these formulas will help us find the slope of the tangent line. And remember, that was tricky because the tangent line only touches the curve at one point. Okay. So here are our two formulas. For today's homework, the textbook will refer to them as, let's see, this first one is definition 1. And then this one is equation 2. It's the way the book labeled them as they were going through the notes in the earlier readings. But you'll need to know the difference for when you do your homework today. All right, so equation 2 we actually looked at in our last lesson. That was the one that we primarily used. And remember, this equation always works. The other equation works when you are given a specific point. Okay. Works at specific point. So you need to know an x value in order to use this equation. So today we're actually going to be working on this one. But we need to remember that the derivative is equal to the slope of our tangent line. Okay, and so when we find that, we are finding the slope of the tangent line. Okay. The next step today, after we find our slope, is actually going to be to find the equation of a tangent line. And you guys have done this before, but the way you find the equation of a tangent line is using point-slope form. But here it is in a little more function notation. You guys are probably used to seeing it as y minus y1 equals, it says derivative, so slope, and then x minus our x1 value. Okay. So if I say find slope of the tangent line, you're going to use one of these two equations. If I say find the actual tangent line, you need to follow through and do the point-slope form. Okay. So example 1, find the equation of the tangent line. So we're not just asked to find the tangent line, we need to find the equation of the tangent line to the parabola x squared minus 8x plus 9 at x equals 3. Okay, and I want to do this using equation 2. That's the one we used last week. Using equation 2. Okay, so that is the limit as h approaches 0. F of a plus h minus f of a all over h. And remember, what this is finding is our derivative at a or our slope, okay, of our tangent line. So this is kind of like step 1 of this problem because we have to write the actual equation of the tangent line. So the first thing we need to do is find the slope. We were using x's last week, so we would have been finding f prime of a. But this time we're actually going to go ahead. We want it when a is 3 or x is 3. So wherever there's an a, I'm going to plug in the number 3. Okay. So f prime, our derivative when x is 3, will equal our limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. And just like last lesson, we're going to go ahead and find f of 3 plus h as a little side note. So f of 3 plus h. Here's my function f. Wherever there's an x, I'm going to write a 3 plus h. So 3 plus h squared minus 8 times 3 plus h plus 9. If I FOIL out 3 plus h, write it twice and FOIL it, I would have 9 plus 6h plus h squared minus 24 minus 8h when I distribute that h, or the negative 8, plus 9. And then I'm just going to combine my like terms. So I got h squared minus 2h. Then I got 9 minus 24 plus 9. So I got 18 minus 24. So I got negative 6 minus 6. Then I'm also going to go ahead and find f of 3. So I'm plugging 3 into my equation that I was given. So I got 3 squared minus 8 times 3 plus 9. So I got 9 minus 24 plus 9. So that's going to give me negative 6. Okay, I'm going to plug that in up here. Still writing limit because I haven't plugged anything in. I haven't plugged in 0 for h. And I will have h squared minus 2h minus 6 minus f of 3, which was negative 6, all over h. Okay. This will be minus a negative 6, so it's really plus 6. So then those two will cancel. And then as per usual, I'll be able to factor out that h. I really want you guys to show that factoring out of the h. Then these h's will cancel. And now I can go ahead and plug in 0 for h. I'd have 0 minus 2, which gives me negative 2. Okay. So this is telling me that my slope or derivative when x is 3 is negative 2. Okay. So now I have my slope using equation 2, and now I'm going to find the equation of my tangent line. Okay. In order to find the equation of a line, I need a point and my slope. I know my slope from my derivative is negative 2, and now I need to find my point. Well, I actually did that. It's when x is equal to 3, and right here I plugged in 3 and I got out negative 6. So my point is 3, negative 6. And now from here, I just need to go ahead and plug it into point slope form. So it's y minus the y value. So y minus a negative 6 equals my slope, negative 2, x minus 3. Okay, this is y plus 6. Distribute your negative 2. That would be a positive 6. And then I would subtract 6 from both sides, so y is equal to negative 2x. Okay. On your homework, the first few problems is it has you find the slope, and then it has you find the equation of the tangent line, and then like step 3 is to graph it and make sure it makes sense. I'm at home, so I can't use my calculator at home, but this is a parabola, and it is opening up, and it has a y-intercept. I could graph it on my calculator too, but you guys won't be able to see it. It has a y-intercept of 9, so I'm guessing we got something like this. I gotta go through the point 3, negative 6. Let's see. It's opening up. We have a y-intercept of 9, so it's pretty steep. Sorry, my parabola is not super great. Okay, third time's the charm. 3, negative 6. Got some parabola here. Okay, and we're at the point 3, negative 6. And what it's saying is the tangent line would, if I graph y equals negative 2x, I know I didn't draw this exactly correct, but it would go, and it would touch just like that. So what they're asking you in like your part C of your homework is you could just sketch a little picture of it, but what I want you to really do is check it on your calculator, and then if you look at the point 3, -6, you should see that the curve and the tangent line are just touching at one point. That's a good way to check to make sure you've come up with the correct answer. Okay. That is example 1. Example 2, find the equation of a tangent line to the parabola at the point 1, 1. Okay, so they're actually giving us the point this time, which is super nice. So what we need is the slope, and the way we're going to find the slope is we are going to use, I want to go ahead and use equation 2 again. And I'm going to just write it out. So we are going to find f prime of my x value, which is 1. And so it's our limit as h approaches 0. So now wherever there's an a, or where we wrote an x on our last lesson, we're going to go ahead and plug in the number 1. So we'd have to have f of 1 plus h minus f of 1 all over h. Okay, so I need to find 1 plus h squared. So I'm just going to do that right here. So I would write it twice and FOIL it. When I write this one twice and FOIL it, sometimes you guys make a silly mistake because you think that the middle term should be 1, but really I'd have 1, and then I would have 1h plus another h. So I'd have 2h plus h squared. Okay. Then I would also find f of 1, which I really don't need to do. I don't know why I'm doing it, because they already told me what you get out is 1. But it'd be 1 squared, yes, which is 1. Okay. So you could also just use the point. They're telling you the x value and the y value here, so you don't need to find f of 1. So f prime of 1, with everything plugged in, we'd have our limit as h approaches 0 of 1 plus 2h plus h squared minus f of 1, which is 1, all over h. My 1's cancel. I will factor out the h. Now these h's will cancel, and now I can plug in 0 for h, and I will get that it is equal to 2. Okay, so my slope, or derivative at 1, is equal to 2. Okay, so that's my slope. So then find the equation of the tangent line. Go ahead, and I have my point. So tangent line. My point is 1, 1. And then my slope is equal to 2. So I would have y minus 1 equals my slope, x minus 1. I would have 2x minus 2, and then if I add the 1 over, I'd have 2x minus 1. Okay, and that would be the equation of my tangent line when x is equal to 1. Okay. That is example 2. Example 3 says find the equation of the tangent line to the parabola y equals 3 over x at x equals 3. Okay, so we're going to go ahead and use definition 1 here. So that is our limit. I want to write that's the derivative. Our derivative at a is our limit as x approaches. Now careful, you guys, this one is not h, it's a, of f of x minus f of a all over x minus a. And in this case, a is equal to 3. Okay, so we're finding our derivative at 3. This one we can only do when we have a specific point. Okay, so we're finding our derivative at 3. So it's our limit as x approaches 3. Now f of x, I already have that, that's 3 over x. Minus f of 3, so I need to find f of 3. So it's when I plug in 3. So I'd have 3 divided by 3, which gives me 1. All over x minus my a, which is 3. Initial end state, you guys, is to plug in 3. And you should notice you can't do it. 3 minus 3 will give us 0, so That would be another hint. Because if you had h approaching 0, if you kind of had the two equations mixed up, you'd be able to, well, you wouldn't have any h's in this equation, but if you thought about plugging in 0, you'd be able to actually find this limit right away. Okay, so there will need to be some form of simplifying. I see multiple fractions, so I'm going to go ahead and get a common denominator. This is really 1 over 1. Then I'm going to times by x, the top and bottom. So I would have 3 minus x all over my common denominator, and then all over x minus 3. And then I still have my limit. I haven't plugged anything in yet, because if I tried, I have 0 in my denominator. I'm going to rewrite this piece right here. You guys like to see the variable first, so it's really negative x plus 3. All over x. And then this is really x minus 3 over 1. So I'm going to times by the reciprocal of that. So it'd be times 1 over x minus 3. I want to cancel these two, but they're actually opposite. This is a negative, and this is positive. This is a positive 3, this is a negative 3. So what I need to do is factor out a negative 1. Now if I go ahead, these two will cancel. And so I'm left with my limit as x approaches 3. It'd be negative 1 times 1 all over x. And now can I plug in 3? Yes, I can, so I'd have negative 1 over 3, which is my slope or my derivative at 3. Okay, so that's the slope of my tangent line. Then from here we just need to find the equation of our tangent line. So tangent line, we got our point, plugged in 3 and we got a 1, and then we have our slope is negative 1 over 3. So y minus 1 equals our slope, x minus 3. I would distribute, and then plus 1/3 times 3 is 1. And then I would add 1. So we'd have negative 1/3 x plus 2. That would be the equation of my tangent line. And that is it for example 3. Your homework. 3 through 7, 9a and b, and 10a and b. So 3 and 4. Okay, so they say to find the equation using definition 1 and equation 2. Okay, so I want you to do both of them. Okay, make sure you do both. And then b is to find the equation of the tangent line. So basically they took our examples and put a and b, they separated it into a and b. We just had one problem. And then C says to graph it, so that's just a sketch, but you should be using your calculator on C. So it has a little calculator symbol, so make sure you do that. Well, maybe my calculator will work. And then 4 is the same way, and then you guys got 5 through 7. So 5, 6, and 7, you guys can pick which definition you want to use. You don't have to, you can either use equation 2 or definition 1 for 5, 6, and 7. I would recommend using at least one of them each time. Sorry. So if you wanted to use equation 2 here, I would use definition 1 or something like that. Just make sure you use at least each one once with those 3 problems. And then 9, you just have to do A and B. You can skip C. It's the same idea. They'll just check it down there. And then 10, A and B. Okay, so finding the slope and then finding the tangent line. I hope to see you tomorrow. If you have any questions, feel free to message me. This assignment, you can go ahead and just add it on to the day 1 assignment. I'll just check all of 2.7 at one point. Okay, so it's just going to be one big 2.7 assignment. All right, have a good day, and I'll talk to you later.